start looking at hypothesis tests when we have two proportions. The first step will be to state our hypotheses. In this case, our null hypothesis will always be P1 equal to P2, and our alternative hypothesis will be either P1 less than P2, P1 is greater than P2, or P1 is not equal to P2. The next step is to calculate the test statistic. In this case, this is P1 hat minus P2 hat divided by the square root of P hat times 1 minus P hat times 1 over N1 plus 1 over N2. And P hat is X1 plus X2 over N1 plus N2. It's the number of successes in both of our samples combined divided by the number of individuals in both the samples combined. So instead of treating them like two different groups, we think of it as one big group and look at that proportion. That would be the value of P hat. Next up is our p-value. If it's a less than test, we use p norm of z. If it's a greater than test, we use 1 minus p norm of z. And if it's a not equal to test, we do 2 times p norm of negative absolute value of z. In other words, the negative value. If it's negative, leave it negative. If it's positive, make it negative. Finally, we need to make a decision. If our p-value is less than alpha, then we say H0 is false. Let's suppose we have two products. Brand A claims that they're more well-known in their product than brand B. In a study, we had 200 people, 124 had heard of brand A. Of 150 people surveyed, 87 had heard of brand B. So we want to test this claim at a 0.1 level of significance. Our first step is going to be to state our hypotheses. In this case, brand A is claiming that they are more well-known, so we should expect more people for brand A, which means our first group should be larger. In this case, our null hypothesis is always P1 equal to P2. And since we want brand A to be bigger, we would have P1 greater than P2. So now let's look at some of our other variables. For brand A, we had 200 people and 124 had heard of them. 124 divided by 200 gives us that P1 is 0.62. For brand B, we had 150 people and 87 had heard of them. This gives us that P2 hat is equal to 87 over 150, or 0.58. Finally, we need our value for P hat. These will be my two groups combined. So 124 plus 87 divided by 200 plus 150 gives us 0.603. Next, we need to find our test statistic. That's given by P1 hat minus P2 hat over the square root of P hat, 1 minus P hat, 1 over N1 plus 1 over N2. Plugging in 0.62 for P1 hat, 0.58 for P2 hat, 0.603 for P hat, 200 for N1, and 150 for N2, and then calculating that gives that our test value is 0.76. Next up, we need to find the p-value. Since this is a greater than test, my alternative hypothesis was P1 is greater than P2. I'm going to use the command 1 minus p norm of this 0.76 value. And calculating that, typing it into R, gives us that the p-value is 0.22. Finally, we need to compare my p-value with my level of significance, and I can see that in this case, the p-value is larger. When the p-value is larger, that means there's not enough evidence to say H0 is false. In terms of the problem, this tells us that there's not enough evidence to say that brand A is more well-known than brand B.